There are innumerable stars outside our cosmic system. However, this one is not normal. For some other, the primary close-up picture of a star outside our system shows a red Goliath that is multiple times bigger than our Sun. Seeing this beast is presently upsetting science. It is 2,000 times bigger than the Sun and a logical sensation, around 160,000 light-years away. Stargazers have found a red Goliath star that they suddenly, and with justifiable cause, named Behemoth. Red Goliaths are swollen stars at the finish of their lives. This peculiarity isn't that uncommon in the universe, but WG64 is not normal for some other. The first close-up of a star outside our universe uncovers a surprising star, as well as one of the most surprising red Goliaths researchers have at any point seen. The star is at home in the Large Magellanic Cloud. This adjoining system has been going with our Milky Way for billions of years. The Magellanic Cloud contains around 30 billion stars. Its shape is sporadic, and it's imagined that this system is the outcome of a prior association with the Milky Way or the Small Magellanic Cloud, which has changed its original construction. Researchers even suspect that the Magellanic Cloud could converge with the Milky Way in a couple billion years. This consolidation would change the construction of the Milky Way, and by new star-forming districts would arise. The forthcoming consolidation with the Andromeda Galaxy could make an interesting dance of three merging galaxies. WG64 will most likely no more exist by then. The giant star will detonate in 2,000 or 3,000 to 100,000 years. Hair-raising picture, thanks to new technology, the Behemoth star. What makes a giant star a beast? Is it its sheer size, the extremely hot fiery blaze seething on its surface? Or is it the trouble researchers have in concentrating on it? Researchers call red Goliaths behemoths, a reference to the book of Job in the Bible, where behemoths are portrayed as immense, fearsome animals. Behemoths are not only strong but also enormous, and in addition, conveyors of exceptional heavenly creation. On one hand, the sheer size of this star is entrancing, and on the other hand, the savagery with which it burns. This star will wreck in the not-too-distant future, during which, when the star has exploded itself to turn into a red Goliath, it will consume everything around it. If WG64 once had planets in its area, they will have been gulped up by the star in a long course of development. So, truly epic and scriptural shows are occurring here. It's estimated that in around 4.5 billion years, our Sun will also start to expand and gradually retain all the planets. Luckily, this moment is reassuringly far in the future. It's a lot more pleasant to notice such an exhibition from a safe distance than to experience it all alone on our vast doorstep. WG64 has been known to scientists for a long while, but up to this point, it was impractical to get a close-up of the star and thus find out more about the cycles on its surface. This has now been accomplished thanks to the development of a totally new strategy. GRAV is another instrument at the European Southern Observatory's Very Large Telescope Interferometer in Chile. The VLTI is one of the most progressive galactic instruments on the planet. It combines the power of up to 4 8.2-meter telescopes with up to 4 additional smaller assistant telescopes. With these so-called unit telescopes and the extensions, the VLTI makes a single virtual telescope that provides unmatched resolution. If we were to set up all the individual pieces of the telescope, we would have a telescope with a width of up to 200 meters. With this strategy, astronomers are indeed achieving phenomenal accuracy with gravity. Astronomers have now expanded the telescope's capabilities even further. This pivotal instrument utilizes interferometry to combine the light from all of the telescopes with GRAV. Stargazers can observe stars and planets with a precision of a few millionths of a second of arc. This accuracy is roughly comparable to being able to see the wings of a butterfly on the moon from Earth. GRAV has now provided the first close-up of WG64, and the data is shocking. The close-up reveals astounding insights. How do specialists manage a close-up of a monster star 160,000 light-years away? Essentially, they meticulously analyze each minuscule bit of light to figure out everything there is to know about that star. The human desire to explore is truly one of a kind, and so we use every technology available to us to uncover all the secrets of the universe. Think about it this way. Researchers can separate every pixel of such a picture into dozens or even hundreds of pieces. Special spectrometers and computer programs analyze the visible light traces, and like criminal investigators, they can read extraordinary details from this data. In this manner, our science can easily find out precise details about a star that is unimaginably far away. Long-term observations of WG64 have shown that the star's light has diminished over the recent years. Now, finally, analysts can figure out insights about why this is so and what associations there are to the star's life. GRAV technology allows researchers to observe the star in real time. And to record processes exhaustively. Specialists caution that WG64 is up until this point progressed that any major change could be a harbinger of its touchy end. Dissimilar to, for instance, scarab juice in our own cosmic area, this red Goliath has proactively started to shed its external parts. The star is already going to pieces, and the egg-shaped ring that you can find in the photograph comprises of this launched-out material, the shape of the case entrances. Researchers, up to this point, no computer model and no simulation has had the option to make sense of how this strange shape occurred. There are actual forces working around WG64 that we don't yet completely comprehend. Since the star's light is now debilitating, specialists fear that further close-ups will soon be impossible. The specialists are intending to update the technology in the Atacama Desert explicitly for this reason. Imagining that noticing a star like this one is of such extreme value to science, no work or cost is saved to analyze this star exhaustively until the end. Is it conceivable that WG64 will offer a unique opportunity to watch a cosmic explosion live in the near future? The Huge Magellanic Cloud, an infinite gem. Let's investigate the area of the exhibition. WG64 is part of the Huge Magellanic Cloud, this amazing adjoining galaxy of the Milky Way, situated in the constellation Dorado or Swordfish. If you gaze toward the night sky, you can see the Huge Magellanic Cloud with the unaided eye. It appears as a little foggy spot in the southern night sky. It was named after the Portuguese adventurer Ferdinand Magellan, who recorded the huge cloud during his circumnavigation of the world in 1519. Around that time, the explorers had no clue that they would see great many other suns and, surprisingly, whole worlds in the night sky. For them, the stars were points of light overhead and signs for their ventures across the seas. The Huge Magellanic Cloud is in our nearby area, a distance of around 160,000 light-years. It's viewed as a satellite world of the Milky Way. The Magellanic dwarf galaxies are likely gravitationally bound to the Milky Way. Designs should be visible in the inside of the Huge Magellanic Cloud that suggests the galaxy is on its way to turning into a curved bar-winding universe. Right now, anyway, its shape is still extremely sporadic and not so wonderful as that of our Milky Way. The Huge Magellanic Cloud also has a width of around 14,000 light-years, which is small compared to our Milky Way, whose breadth is an entire 100,000 light-years. A particularly gorgeous component of the Huge Magellanic Cloud is the Tarantula Cloud. The star-forming district is one of the most dynamic in the nearby group of galaxies. The Tarantula Cloud is so enormous that it's noticeable to the unaided eye as a brilliant fix. It contains young star groups like R136, which is home to the most gigantic stars known. R136A1 is a blue hypergiant and the most enormous star known in the universe, with an expected mass of around 200 solar masses and a radiance around 8 million times more brilliant than the Sun. It is a true behemoth. Also, anyway, R136A1 is at the start of its life. When WG64 will detonate in the not-too-distant future, the star will heave its mass out into the universe. From the residue of its blast, new stars will be formed in star-forming regions, such as the Tarantula Cloud. Obviously, it would be a genuine delight for science to have the option to watch this blast. The Huge Magellanic Cloud has previously offered the chance to notice such an uncommon exhibition. In 1987, the cosmic explosion SN 1987A was seen there. This was the first cosmic explosion in hundreds of years that was noticeable to the unaided eye. For modern researchers, it was the first valuable chance to study the blast of a withering star in detail. Betelgeuse, Will we see the cosmic explosion soon? While we're discussing supernovae and red Goliaths, one should not be missing. Betelgeuse is the most conspicuous star in the constellation Orion, and it will also detonate soon. Anyway, Betelgeuse has not yet begun to shed its external layers. The last blast is probably much further in the future than that of WG64. In 2019, it was seen that Betelgeuse turned out to be considerably dimmer for a while, prompting a lot of speculation. Some researchers saw the end of the star, which is around 550 light-years from us. However, at that point, the circumstance quieted down again. As a red supergiant star, it has already consumed an enormous piece of its atomic fuel and will totally deplete its hydrogen supply later on, prompting a final blast. The exact time of this event is hard to predict. We don't have enough experience with dying stars to be able to predict the final stage with certainty. Thus, similarly as with WG64, analysts are noticing every single change on the surface of the star. The definite reason for the adjustment of brilliance of Betelgeuse in 2019 could be explained by an immense mass discharge. Betelgeuse has balanced out again after this mass loss, and it remains unclear at what point the star will detonate. Red supergiants like Betelgeuse have staggering amounts of material swirling around inside them. This also creates strong convection flows in the outer layers. Also, sometimes, much of this material is launched out, causing it to go into obscuring. Betelgeuse wrapped itself by the material launch, likely in addition to a little while, into a thick dust coat, and consequently, the star lost optical brightness again. This coherent explanation was given first. Betelgeuse had just hacked like an old, feeble man. However, researchers caution that, hypothetically, the last blast can happen any moment. Clicks buying in at this point, new recordings are not far off.